Okay, let's get right to it here. Go ahead, start marking your diagram for me. Ready to get talking now. First step, prove BC congruent to DA. BC congruent to DA. All right, oh boy. This is probably the third time I'm going to let you guys in on this. This is not a two-step proof. You cannot tell me BC congruent to DA because in a parallelogram, opposite sides are congruent. What did I give you this figure was? Not a parallelogram, but a? Okay, you know nothing then. You know nothing. You cannot use any parallelogram property right now. So we need to get to BC being congruent to AD a different way. And if it's not a parallelogram, what's the only way all year long, since unit 4 anyway, we've proved two segments congruent by proving the what congruent first? Find me them. Where are those triangles that contain BC and DA as full sides? I got triangle ABC, and I'm going to have right on top of it ADC, this one right here. So the yellow and the blue one right now. What do I already have? I already have B and D, right? Congruent. So there's a pair of angles. Can you guys get me anything else on your own? Anybody see anything else on your own? What's up, Holiday? Okay, here's the problem. They are vertical, but are they in those two triangles? So they're not full angles in those triangles. So right now, they're not going to do me any good. You good? And I know where you're going with this, but I'm just trying to focus on these two right here. For now, anyway. Okay? Michelle. Oh, killing me. Oh, she went there. And you're going to say it's a parallelogram. I hate to break it to you, and there's other people in this room thought the same thing. FE, take a look at FE. Not a diagonal. Everyone else, yes, not a diagonal. I was going to get there when we got to part B, but now that we're here, FE is not a diagonal, so you can't say they bisect each other. Well, they do bisect each other, but FE is not a diagonal, so not a parallelogram. Okay, back to my original question. Is there anything else in those two triangles that you can tell me? Letty. AC is shared in both, a full side. So I could say AC congruent to itself. Okay. Is there anything else you can tell me in those two triangles? And here's a hint. Don't raise your hand. Anything else you can tell me in those two triangles? I told you don't raise your hand because there is nothing else. You cannot find me a third pair of anything. Anybody want to try it? Let me know when you get, okay. Sure. Why would you say 4 and 3? What's your reason? Well, what's your reasoning going to be? Okay. Other questions, concerns? So what am I trying to tell you guys? Can you prove those two congruent? Not right now, we can't. But so you know where we go when we can't prove a pair congruent? We go to another pair. And now, Holiday, what are you going to tell me? Angle 1 and 2 are congruent. Everyone see the triangles we can prove congruent. Vertical angles are congruent. Everyone see the two triangles? Are they congruent after I said 1 and 2 congruent now? Do I have it? Is that safe to say both those two smaller ones are congruent? Okay. So let's say, start naming them now. Triangle. Somebody give me a name of one of them. AGE. So if I go AGE, in the other triangle, I must go, let's see, CGF. Everyone calm down. I got it. What's your methods? Side angle, side. What's going to help you out in those two That'll finally get me to the bigger ones. Take a look. Find me a pair of angles or sides that are shared in both. You can do it. And the triangles we just proved congruent, there should be a pair of angles or sides staring you in the face that are shared in the big triangles too, and they would be angles, angle 3 and angle 4. And what's going to give me the right to say they're congruent? CPCTC. And do you see now that that's the missing link? Go ahead, Michelle. Okay. Everyone's good? Now can I prove the yellow and the blue one's congruent? Yes. By another side angle side. So go ahead, name that triangle. Name one of them. CAD. Sure, CAD. If we go CAD, everybody, we got to go. If I go CAD, we got to go ACB. Side angle side. And now finally, okay, everyone calm down. I got it. I heard side angles. I'm just making excuses. It's my fault. Is that side in the middle? Nope. So it's going to be angle side. And now what two segments are congruent? BC and DA by CPCTC. So just another prove a pair to get a pair. And then we get to part B. Prove it's a parallelogram now. We did all that work for a reason, just not to answer part A. That is going to help us saying it's a parallelogram because these are parallel, right? And not parallel, sorry. Congruent. Everyone agree? Where could we go from? There's two different ways, and I don't want to give it away. There are two different ways we could go right now to make that into. Here's what we got, right? How do I make that into a parallelogram now? There's two ways I could go. Letty, I could prove the other pair congruent, or I could do what? Maddie? Well, don't even mention anything as far as this diagram goes. I could prove these are also parallel, and we can do both. We can prove these congruent, or we could prove these parallel. Is there a class decision on what we want to do? Parallel or congruent? How many parallels in the house? I got to actually count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many congruents in the house? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, great. You guys don't make it easy, huh? Oh, boy. How are we going to figure that? Okay, ready? Oh, great. What playground style right now? Playground style. Give me who's a parallel person? Parallel? Maddie, come on over right here. Who's a congruent person? Letty, let's go right here. 2 out of 3, rock, paper, scissors. Playground style. Playground style. Here we go. Duking it out. 2 out of 3. There we go. Got one. Ooh, 2 in a row. You're a congruent person, right, Letty? Here we go. How can I prove the opposite side congruent? They already are. You just need to tell me. CPCTC, right? Because they're in the 2 triangles we just proved congruent. So in step 7, I'll just put a little comma and say, hey, so are the other 2 pair. BA so the other pair. BA congruent to CD. And just to give you guys your own moment, you parallel people, how would you get that same side's parallel? We already know 3 and 4 are congruent, and they're what types of angles? Alternate interior implies parallel lines. Okay? So now we could say ABCD is a parallelogram. Reason? both opposite sides, in this case, congruent implies parallel lines. Okay? If you wanted to do the parallel way, that's fine. Just say one pair of opposite sides are parallel and congruent. Bella! That rock, paper, scissors just threw me all off now. That was a beat down. Beat down. Got to go back. Got to go back to the drawing board, Maddie. I always throw scissors first. Always throw scissors first. There's a whole bunch. Somebody's going to say that go. For some reason, people always think rock's dominant, so they're going to throw rock. So that means I got to throw paper. So if they're going to throw paper, I'm going to throw scissors at them. See you later. What's that? Second? Ooh, that's just a toss-up. I have no idea. Oh, I always go scissors first, though. Okay, here we go with this last one. This last one is not a long one, but I want to make sure we got the correct wording in the statements. So take a quick look. You got a parallelogram, and you're proving another parallelogram. All right, it almost looks like I can do what to prove the AECG, a parallelogram? Because here, look, here's what I have right now in EAGC. And there's F. Here's what I have right now. Almost looks like I could do what property? Diagonals bisect each other, but do they bisect each other yet? No, one diagonal bisects the other, but they don't bisect each other yet. Anybody see a way I could get AF congruent to FC? And I don't want to prove triangles congruent. There's a hint. I don't want to prove triangles congruent. Any way I can get AF congruent to FC. Hello, Bella.
AC is the diagonal in both. So, like, you could say that FC is congruent to AF is the other parallelogram.
Does everyone see parallelogram ABCD? Do you see the two diagonals, AC and BD, in those? Everyone sees those two. What are they doing to each other? Bisecting each other, which would make what two segments congruent? AF and FC. But this is why I'm doing it with you. We are not ready to say AF congruent to FC because it's a parallelogram. What's the property of a parallelogram say? Not that the two segments are equal, but what? The diagonals bisect each other. So that's what's going to go next, is that AC and DB bisect each other. That's what the parallelogram property says. It's not saying that the two little segments are equal. So parallelogram implies diagonals bisect each other. Now you can say what? Now that you know they bisect each other, yeah, now you can say AF is congruent to FC. Because what? You know your knowledge of a what? Not because it's, this is not true because it's a parallelogram. This is true because it's a bisector. All right, definition of a bisector. So now I have those two segments congruent. Is it a parallelogram? It is. What's going to be your reason, though? Why is that a parallelogram here? What's going to be your reason? Diagonals bisect each other. Did you tell me that, though? No, so we need to say that. You're not ready to say it's a parallelogram yet. You got to tell me those two diagonals, AC and, what's the other one? EG, bisect each other. What have we been writing for a reason? How are you going to tell me they bisect each other? Let's finish strong. How do you know? Andrew. AF is congruent to CF and EF is congruent to FG. Yep. And now you can say in step 5, this bad boy is a parallelogram. All right. Please make sure that textbook work gets tried tonight, and I'll answer any questions tomorrow.